There we go. Hello everybody, welcome to another stream. How we doing? There we go. And this one. I don't know what I'm doing with my audio. I don't know how I'm nudging this. Right, let's try that. I'm grossly unprepared today, apparently. But hello, welcome everybody. Where the hell is my... There you go, chat only on my phone. Finally. Okay, so last stream, we made some progress and we discovered that, when we was applying the lighting, we was doing it in sRGB space and not linear, because in the, when we get the sphere color, calculate sphere color in the shaders, I quickly put this together and I had this the wrong way around. So I'd unpack the color into a vector 4 color, right? And I then multiplied it by the normal dotted with the light direction. And then I did the sRGB to linear conversion. So that was causing it to be darker, and you see the LOD. Let's turn off the blending of spheres. Yeah, it'll cause it to be darker, I think. Yeah, across the different LODs a lot more. So we fixed that, and then if we turn off these two things, yeah, you don't see much of a change, which is great. When the LEDs change in, you still see it here, for instance, and it's also really bright right now. We should probably reduce the brightness of the spheres. So I think it's here. Let's make it half red. The SLB was visible at the coarse LED, yeah, that's right. So it was more visible at the highest level of detail. That's a bit too dim now. It's in sRGB, that's why halving it is not going to half it. It's kind of exponential. Right, should be back there. So my cable got nudged again. And I'm back. Yes, it's kind of exponential, so maybe we should just do like CC or something like that, I don't know. There you go, it's kind of bright enough. Not too bright. So what we're doing now is we've got this sort of, to help avoid seeing the pop in, because you still see pop in. If we increase the size of a cluster before we change the LOD, you still see stuff pop in at this level. Right, this is unrealistic, we probably wouldn't do this, but you still see stuff will pop in, especially around this area here. Stuff sort of comes and goes, and it's you'll see it. So on like probably like a lower end hardware, yeah, so you still see it there. It sort of pretty pops there. So to reduce that, we alpha blend. between the two LODs, there's alpha blends. So you don't see, so the change, it still changes, but it's just smooth. So if you look here, now it's not very, it doesn't pop in anymore. It just sort of fades in. So we might try and reduce the amount of time it takes to fade. And we're going to work on that after the anti-aliasing, because this is a big problem. You'll notice if I turn on anti-aliasing, it gets darker. Took some screenshots last stream, and we found out that yeah, it's adding more outlines to the spheres. It's adding more outlines to the spheres like these dark pixels here. It's a bit blurry, this screenshot. The zoom tool's a bit blurry. So what we want to do is redo the anti-aliasing, so we'll go over what the current method is, and then we're going to go ahead and do a new method, which should hopefully reduce the amount of dark pixels. Let's get Milton out. So the current way we do anti-aliasing is, oh, here's one I did earlier, because we ended on it last stream. Oh, by the way, I want to test out this marker system in Twitch, because I want to start doing some videos and I want to see how this adds to the VOD and how this works. So I'm putting a marker down in places where I think I might be interested in looking at again. But I'm not going to make a video for this stream, it'll be in future streams. So I'm just sort of seeing that, how that works. Okay, so how does the anti-aliasing work in the current setup? So what's really nice is that we ray trace. So there's nothing on the screen, we do ray tracing, then there's everything on the screen. It's like a forward render, right, approach. So there's not anything deferred, and I think I don't want any. We might do some things deferred, but we're probably going to have a forward renderer. So basically, all you need to know is we have our ray tracing goes over all the spheres, front to back. And so this means it can do transparency, it can do anti-aliasing also. So how we do anti-aliasing is we have our ray, which is this guy here. And when we check the sphere, we go, hang on a minute, we've missed the sphere. So we take the vector, which is from the camera to the center of the sphere, and we use trigonometry to basically get this distance here from the center of the sphere to the ray that missed, or the closest point on the ray that missed. And then we can use that to figure out, are we a pixel away? Imagine if this is the size of a pixel on the screen. Like this is, well, the pixel on the screen might be like this size, like very small, but as it's projected out into the world, it has basically became bigger. So we use this sort of rough, it's not 100% correct, but it's cheap. So we use that rough estimation to know how big of a pixel is in view space at this point, right? So we now know that we have missed the sphere by less than a pixel. So we use this pixel to do be the one that we treat as transparent. So this is where the darker spots are coming from, because, well, that's what we think at least. Because you might have a light. So the light direction is coming from here, but it's like a bit up, further up. So what we do is we recalculate a normal based on this position to here, so we get this sort of like direction, and that's the normal. Well, that's perpendicular to the light, so it's going to be black, right? Because it's basically 0. So it's going to multiply the red by 0, and then that will be blended on depending on how much alpha is accepted onto this, yeah, onto a sphere that comes behind it, basically. So I think this is where the darkness is coming from. So the new approach that we want to do is instead not do this sort of miss approach, but instead, so this is like an outset AA, we want to do more of an inset AA. So we're going to instead say, hey, if you're hit, so imagine we draw a new ray this time. This time we do it in red. So say if the new ray is a hit, and why did I do it there? If the new ray is hit and is it within a pixel from the edge? If that is true, I guess we'll do something like that again. Yeah, we've got the hit point. Work out this square distance of that. If it's a no. How can you work it out? Yeah, you probably have to do something like, yeah, I don't know how you work that out. Let's figure it out. This is your screen right now. So you got your screen where it hits inside. You need to work out if I guess you could get that, and that's the radius. You already know. To say if like this is the range, and then you want to be in, and maybe this is the second pixel inwards, if you will. So if you had another ray which instead went there, you don't want that one to be the anti-aliasing, right? So how could we figure that one out? Well, radius is the outer part of the pixel versus the inner pixel. Well, radius is the outer part of the pixel versus the inner. I'm not sure what you mean. Rest must go. Center of the right, center of the minus 0.5 pixel size versus center. I'm not sure what you mean there exactly. So, can you rephrase that in any way? Yeah, I don't know if. I don't know how you would check. If the outer part of a pixel is inside a sphere radius. Ah, right. If the pixel is inside the sphere. Right. I see. Right, so let me draw it up again. Afresh. So what you're saying is you cast a ray. Right, so let's draw the pixel. Let's draw it in red. Let's say here's a screen pixel. So we cast a ray and it hits here. Wait, you're casting a ray through the pixel, isn't it? So you're casting it through and hitting there. Perfect, okay. Right. Yeah, okay, that's a good idea. You're casting it through the ray anyway. Um, you can then get the you can get the distance. Hmm, that's surely always a constant, that distance from there. That's just radius. Um, but yeah, so if the pixel, maybe I'll draw another one. Say we have another pixel which is like just hanging out like that. Let's draw a ray. Kind of similar, that one, isn't it? Draw a bit smaller for some reason. All right, let's try that one out. So if the inner part is outside the sphere radius, pixel is completely missing sphere. Yeah, so we're casting it through the center of the pixel. Yeah, so it's always about this outer part here, right? Yeah. So I see. Let's see. Um, so what you say in the Rosmusco is we're only going to get a range of 0.5 to interpolate the anti-aliasing, right? Um, because if I'm casting through the center of the pixel, and the pixel misses by 0.7, then it means um, it's a complete miss. Or do I need to handle the miss case as well? Maybe I need to draw that up. Let me draw another sphere. So the example is when you cast a ray, so if it just touches, it'll be 1. Which means you might as well not calculate it, right? You might as well not calculate it. Oh, I've ran out of the wrong color. Yeah, your ray just goes straight through the center there, just misses sphere. Yeah. Then it ramps up to 1 over a distance of 0.5 pixels towards the sphere center. Right. Still not sure what you mean there. So in this case, this is a miss. Oh, my day is crazy. Terrible drawing. Yeah, so I guess what you're saying is, let's say this one misses because it goes through the center pixel, and it just misses the sphere. This one, we don't bother doing any anti-aliasing for it, I think. Because currently we would do the missing, we will do the miss stuff, and you're saying don't do it for this, no? That one would have 0.5 alpha. See, are we already doing this? Ah, okay. Yeah, maybe I just need to tune my anti-aliasing there. Maybe it's a bit wrong. So we still need to do the miss strategy then. So if it hits or if it just misses. Okay. I see. Right. That makes sense. So this one here you would get, yeah, that would be the 0 to 0.5 alpha. And then this one would be 0.5. This one would be probably 0.8 alpha because it's only a little bit of it is missing. Right. I see. Okay, so let's go to the shader where that happens. Awesome. Thank you, thank you. So it's in the tiled ray tracer, right? Because that's the acceleration structure. It's just an array of spheres that we go over that are sorted from front to back. So because they're sorted from front to back, we can do alpha blending, and it's amazing. So, right. So, how do we know? Like, we handled this case already. We can just quickly go over that. If we did not hit, and anti-aliasing is enabled, we've got it as an option we can toggle now. We do the ray to sphere origin, as we said earlier, ray to the center of the object. We get the hypotenuse squared, which is the longer side of the triangle, and we use the dot product of the is the dot product of the sphere to origin vector and the ray direction to basically get the depth along the Ooh, the depth along. Where's the right angle? To get the depth along the. That's the hypotenuse. To get the depth along the ray, basically. And then we get this as a squared number. Although, sorry, the length of that is a squared number. But in this mouse here, and then we calculate how big a pixel size is at depth. So the problem is with this one, is it's doing pixel size. We want to get the half pixel size at depth. That's cool, no worries. You helped me out, it's good. Man, it's so confusing with you guys. You both got the same, like, you both have the VIP gem thing, and you're both orange and start with R. I sometimes get you guys mixed up. In my toy ray tracer, I only do anti-aliasing. Recast the ray for the miss case. So I can take the fast path if the ray hits. Effectively, the results are if the spheres are enlarged by half a pixel. Maybe you should invert that. Miss is the fast case. Oh, you should invert that. Alright. Yeah, I guess you can change the size of the sphere though. It wouldn't be... Yeah, that's another way to do it. Definitely another way to do it. I guess this might be... Yeah, so if you miss, you'll increase the size of the sphere by a pixel. And then, yeah. Rerun it again. Retrace it against it again. I guess by that logic, you could just increase the size of the sphere by half a pixel anyway, right? Increase the sphere by a size of a pixel, and then if you hit, check if you're near the edge. But then your normal is going to be off by a bit, maybe, because it's a tiny bit bigger. But I wonder if that's okay. What do you reckon? Because then you don't have to do two traces, right? You just do the one. That's the other way of doing it. Oh, we should try that out. Maybe just increase the size of the sphere by a pixel. And then, yeah. So, alright, so that all works out, I think. Zoom to my phone. Right, my phone's lost the chat. Down this thing. The ray should be adjusted towards the sphere center. Or the alpha blending case approximate to average the color of the area covered by the pixel. Should be adjusted towards the sphere center for the alpha blended case to approximate the average color of the area covered by the pixel. Yeah, I don't know, maybe. If the sphere is small, I definitely see that case. But then if the sphere is big, maybe not. But yeah, so you're saying it can get quite dark towards the edge, can't it? Maybe. Right. So we've adjusted this case now. What I want to try and do is I want to try and solve the other problem now. So if we do a hit, did we hit with some amount of our pixel near the edge? So how would you even know that? See, unless you just reduce it by So the way we know right now is we get this distance here, but presumably if you hit see, I wonder if closest round point sphere distance. I wonder if that's just always radius, and you don't need to calculate it. Oh no, it won't be because it's missed. But yeah, I wonder if we do that here at all. I wonder if this is going to be your ray to the center of the sphere, and you calculate this. This is always going to be radius if you've hit the sphere. It has to be. So I wonder, how do you say if I'm... Because you're always going to be. But you want to know based on along that plane, basically. Along that plane, given my point, yeah, it's easy to do. It's a bit of maths. Damn it, my phone. Can't even see the chat anymore. That's all the... There you go, much better. It's on my phone now. And also get a color at all of the missed rays. Okay. Yeah, we'll play around with that when we do these changes. But yeah, that sounds interesting. Because I'm not sure if the sphere has a constant color. Yeah, I think we can calculate this one quite easy. We've just got to get the perpendicular vector to the ray along the x. So it's quite easy to get. So you get like a perp. You have like a perp perpendicular along the x. So that is just ray. So you put the z into the x, and then you put you keep the y in the same place, and then you put the negated, wait a minute. I think it doesn't matter which way it's pointing along the x, I think. Yeah, it doesn't matter which way it's pointing. Wait, it does. You need to be pointing to the I think it doesn't matter, so you just negate one of them. Alright, we'll play around that for a bit. So you get that perp x vector. So you want to take your so I guess you can get the vector to the closest hit point, and you can also, and you want to reproject that across that new perp plane, I guess, if you will, the one that's perpendicular to the where the ray is shot. Wait, where the ray is shot. Where the ray is shot. So produce something. That. Yeah, because this is the ray. So you reproject that across there, and with that information you can tell, you know, like, hey, the sphere ends here. Am I within a pixel away? Yes or no, or half a pixel. That should be enough. And then if you had the ray which went here, similar story, you would plot it there and the other one will plot over here. That's not half a pixel distance. So it's quite easy. So your closest hit point is here. You have a difference to the center of the, so you say so sphere center to closest hit point vector. So that is then a subtraction between closest point, and where's the sphere center at? S dot center position, I think that's it. So now you got that vector, you reproject that, so you get your sort of like I don't know, let's just call it T or something. Figure it out. There's just the dot product. Yeah. So how much does this vector with a magnitude reproject onto this normalized perpendicular x-plane to the ray's direction? And then we want to absolute it, I think. Good idea, absolute. So you want to say distance to edge, and then so that'll just be an ABS of float 32. And then you want to say this, you want to calculate your alpha, or AA alpha, if you will. And that will be saying I take the radius of the sphere, minus distance to edge. So so this will get you a number between 0 and, sorry. So this is typically, this will always be bigger. So yeah, it'll get you from, yeah, so I guess you'll get like 0 to 0. Yeah, from 0 going all the way up. So here we want to probably minute, find the minimum with 0.5, if you will, and then add 0.5. So this will give you a value between 0 and 0.5, and then we add 0.5, so the range becomes between 0.5 to 1. So then we can use that to do the coloring. So color, then we take this and then say color.a multiply equal to anti-aliasing alpha. And then we do the blending from front to back and apply. That should hopefully improve the image a bit. Let's give that a go. All right, let's see how we do. Okay, so let's toggle the anti-aliasing. Right, we still get some issues here where it is appearing darker, but I don't know if we can. This is specifically the external one, because this is the only one that's toggled by the option. You see, I wonder if we can have a bit of fun here. Do we see a difference in image? Do we see a different image if we just change the anti-aliasing for the one that misses, that just about misses? We see. Right, the image does get softer. You do see it. It does get a bit brighter as well here. So it'd be good to get a screenshot and compare. This is unfortunate, this setup, but it's okay. We'll be improving it very, very soon. So after we've done this sort of anti-aliasing thing, what I want to work on is a screenshot, taking screenshots in the game, but also viewing textures in the game and comparing screenshots. It shouldn't be too much work to do. But yeah, that's what we want to do afterwards, because this is a bit of a dance. But it should be just a few clicks. They even try and do the drop shadow like on Mac. Oh my days. I'm gonna take the screenshot. Okay. So that's anti-aliasing off. Is why? Right, turns out I got to do a different way of doing the capture. Because it would move the image. Alright. Right, as you can tell, it's super fiddly. We need to improve that process to streamline it. So that's what we'll be starting on Sunday, is doing a tool that will mean we can just compare images really easy. But anyway, so anti-aliasing off, anti-aliasing on. So let's see what that looks like here. So on is getting rid of some of the dark pixels. Yeah, it's getting rid of some of the dark pixels and all of that. Off, on, off, on. So that's interesting. Let's see it around here-ish. Saw some change. Off, on, off, on. This one is actually making it brighter. This part of the anti-aliasing, at least. Wait a minute, those dark pixels are coming from the other anti-aliasing, which has been always enabled. Alright, it's a glitch. Right, so this type of anti-aliasing still introduces some form of like dark. Pixels. Ooh, I wonder how that compares. I guess let's take a screenshot with just this other one. And this image... Oh, as the camera moved. Damn it. I got some ideas. I want to get it exactly right. But I guess I did move the camera on the last one. Already fair, is it? Okay, this is why it's good to have an in-game tool to do this. Hmm. I wonder if there's another way that we could do the anti-aliasing. I wonder if... We can instead increase it by a pixel. And then just do a full miss rather than a 0.5 miss. And then it is actually far quicker. And we wouldn't have to do... Because the problem with this code, right, is you've got 32 threads running in lockstep. And they go into here and they all execute. They're all running and executing the, 32 spheres in lockstep. and doing this. But as soon as you get to here, if they all hit, sure, they're all going to here. But if they don't all hit, if some miss, it will execute this side of the branch, and then this side of the branch across all those 32 threads. So you get some wastage. So perhaps maybe the incorrect thing, and maybe, maybe the best thing to do is just simply increase the size of the sphere by a pixel and just calculate the anti-aliasing by how much we are near the edge. And it'll be slightly incorrect, but maybe it's just the best way to do it, perf-wise. Because that's what you do when you do anything that's 2D. Typically, it's just increase the size of the object. And maybe it's okay in 3D too. But you don't have to recalculate the normal in a funny way either. So I think this could be the approach. So just going to increase it by a pixel. So we've got that size, that rough estimate here of pixel size in the eclipse plane. So we need to move that out. We need to multiply it by depth. So when we've hit, we get t, which is the depth, right? So we get pixel size at depth. Where's that? No, but that's when you do the hit. Sphere to center. Maybe you have to do a length up. Not ideal. So I guess in this ray versus sphere, we do this ray to sphere. We do a length squared on that. So we avoid the square root. So maybe, I guess I can just do it outside the function, it's not a big deal. It's a little bit extra maths, but it should be better. So radius sphere, and then let's take the length of that. So get the pixel size at that. It'll be a bit off though, wouldn't it? Because if your sphere is big, you're not getting it. But to calculate the depth, it's only this many instructions. So maybe, and you get some sharing with that variable there anyway. So theoretically, it's just these two. So maybe just doing this beforehand isn't that bad because the optimizer will sort that out, and then we're not doing a square root. So now our depth, all we have to do is say pixel size at depth, pixel size in the eclipse plane multiplied by depth. So we need to increase the sphere by that. So you say s dot radius. I think that's the thing. Right, so increase the sphere by a pixel size for anti-aliasing. So if we hit right, so I think that's better. Let's try that out now. Be slightly incorrect though. Oh, for crying out loud, guys. I'm sorry. I thought I was seeing the chat, but my phone's messing up. Let me close the Twitch app. Apologies on that one. Um. Oh, right. The missed case goes from 0 to 0.5. I see. I see. That's cool. Right. I don't think you fixed the outside one properly. Fair enough. What unit is s dot radius and distance to edge? Yeah. What unit is that? That's in view space. Oh, am I on here? Yeah. I guess. What unit is that? They're in view space in meters, I guess. Oh, that's a good point. Sphere dot radius is a different. No, it's in view space. Yeah, they're both in view space. Yeah, everything's in view space. Let's just double check that. That's a good point. Yeah, these are binned into view space. Yeah, I'm not sure how that works. There should have been pixels for alpha and clamp to make sense. Yeah, that's a good point. They would need to be in pixels, isn't it? Because this is view space coordinates. View space meters. Whoopsie. So that would be... I could do a divide. Yeah, I don't have to bring it back into the screen though. What did we do in the other one? What did past me do? Yes, I brought it back into screen space. Okay, hopefully that chat works now. Okay. So you've increased it. This will be some distance in view space. Then we want to turn it into... What? Was this even correct? World space. That's meant to say view space. I mistyped the... So distance to edge. Distance from edge in view space. Distance from edge in screen space. So we do like a divide by depth. Um, divide by depth and then divide by pixel size and near clip plane. You can optimize that later, those divisions. So with this, it'll be in screen space, and that will hopefully work better. Right, thank you there, Rosmusko. Yeah. Okay, let's try that. Right, so turn off anti-aliasing, turn it back on. It is still getting darker. Oh, it's getting lighter when you turn on the anti-aliasing. Let's turn off the blended stuff. Okay, so now it's the other way around. It's getting lighter when you turn it on. Interesting. Should we zoom in and see what sort of what we see? Do we see? There seems some sort of fuzziness here. It's happening. I guess that's probably incorrect. That's a bit weird. It's not pixel size out, is it? Something's off with the way we increase the spheres, perhaps. Okay. Yeah, I'm not quite sure. So that could be... They're quite squished here at this point. Maybe the inaccuracies of the function are really showing up. So should we just render the alpha? That's probably a good approach. Let's just render the alpha. So we're going to say yeah, so just render the alpha only now. See how that goes. Wait, what am I trying to do again? Fading on the inside will produce a bias towards normals facing the camera, even when the spheres are increased in it. Even when spheres are increased in size. Right. Yeah, because when you increase the spheres, you'll get the inaccuracy of the normal as well. Yeah, I was wondering if that would be. I was wondering if that would be an issue, but I don't think. I don't know if we can rule out of that being the problem at the moment, because we've got an issue where the rendering. That's terrible. Where the rendering is you've got this glitch here, whereas it feels like they're a bit too big. That's not a pixel, that's like many pixels. So perhaps the lightness is coming from something like that. Um, um, sphere from edge. It's a bit warm now, I'm just gonna crack a window open. Hey there, Guru. How's it going? Oh. Um, so distance from edge in view space and in screen space. So yeah, we're increasing the radius by pixel size at depth. Is that correct? um, yes. Yeah, that seems all right. We color it maybe to see it. No, and then we do the. Hmm. Right, center towards the closest point. They're all in view space. The dot products across the perpendicular ray direction. Absolute. Distance to edge. Um. Right, I think I can see a problem because towards here. Right, it's interesting. So what you can see is this, the way this is shaped is weird, right? And the vector we're putting it onto is in the x-axis in view space. But how would that be with the projection? So no, we're swapping. So if the ray is going that way, we're swapping. It's fine. I think the maths is fine. So we're getting, if the ray's going this way, we're swapping the z and the x. So we're getting this perpendicular vector here. Yeah, so we get the distance across that vector and we absolute it. That should be okay. It'll be a bit off though. Will it be okay for stuff going down though, actually? At that. You find a ray down into that. You get in the perpendicular x. So it's coming from this way. You get in sort of like that vector, you're not getting... Can you use the discriminant instead? I'm not sure on the maths behind it. So maybe that's... Yeah, maybe that is an approach to use. So where is the discriminant in this drawing? I guess it's hard to ask you that question. But yeah, maybe that is an approach. I haven't considered that. So you've got this maths here. So this is the... So we already do this here, the midpoint. Oh, we did that before. Double check that. Ray to sphere, ray direction, depth. Right. This gets you this thing called midpoint. Ah, interesting. I think I can understand this a bit. If your ray goes here, you're getting this anyway. Sorry, you're getting the depth along here. There's too many things. Let's draw another one. So your ray goes through. I think you got an idea, decoding it a bit. So, and you got a distance to the center of the object. So you do that vector, so the vector just drawn, dotted with the ray direction, so this one. That gets you, so you've got a distance. This gets you the depth to get to this point here, projected along this ray. So it's the depth to get to there. Right. And then by squaring that, distance and squaring the radius distance, we did this as well. I think it's a bit of trigonometry maybe. By squaring the distance, yeah, by squaring the depth and squaring the hypotenuse, that's a different one. That's a different yeah, that's a different value. And maybe it's kind of trig, I'm not sure. So we squared it and took it away. So I think there's a bit of trigonometry that, so that radius would be the distance from here to here, I imagine. Right? That's that distance. And it's squaring those two, I guess. Adding them together, taking away that. So I guess this is getting you... Right, so this just means you haven't hit. So maybe you could just use that. I see. This might get you... So if it's less than 0, it means you're on the inside. Yeah, perhaps. So this would be in view space, this unit. So maybe we can take this and just check if we are, maybe bring it to screen space. And check if we've missed by a pixel or not. I think that could be right. Maybe that'll work. Hey there, Green Blade, how's it going? How you been? Been a while, that's for sure. Yeah, I think that's right. I'm not 100% sure on the maths, but based on what we've already written in the past, it seems kind of similar. Maybe we can pass that out and just give it a go. So if you hit or miss, take this. Awesome. It's been grinding, fair play. Sounds like you've been nice and busy. You've been working on a lot of personal stuff, like personal projects, or is this like other projects, like work, work? Um, yeah. So I guess you do the whole hit and miss thing, maybe. I think that was a bit silly doing that. So yeah, we don't increase it by the pixel size anymore. Instead, we've got that discriminant thing. We should be able to take that. I'm saying it's the distance from edge. I'm not sure, but let's just imagine it is. We'll have a play. I think that's right. So it'd be 0. We're going from 0 to 0.5, and then we're going to add, because we're on the inside, we're going to add 0.5 to make it 0.5 to 1. No, this won't work. Fair play. Fair play. Distance from edge and screen space. So the depth in this case would actually just be t. Line 4K, what about it? Yeah, I got plenty of lines. 5,000 lines. More to come. This is the way. Hit.t, that's depth. Just, I like to rename it there for make it more readable. So let's get into screen space. Shoot, what am I doing there? That's kind of wrong. I should have done that here. Whoops. Excuse me from being a wally. So that's just distance from edge view space. No, it's not in one file, it's in a few files. This is just all the shaders in one file. But yeah, I try and keep stuff in as few files as possible because files kind of suck if you have too many. So basically there's one source file per module with some exceptions. Sometimes I have a few more header files, right? But one source file typically. It's just where all the custom collections go and allocators and that. You know, the UI has just got one file, I think. Yep, a couple of headers, right? Internals, public API, shared between the CPU and GPU headers. Yeah, the GPU has an extra source file specifically for the Vulkan backend. So any Vulkan code just goes in there. So basically I just use source files as a way of separating whole systems, if you will. Yeah, so whenever you add more layers, you basically have another source file. Yeah, so OS, Linux, OS, Windows. So it's just a lot easier to navigate and reason about, because, yeah. Basically, if you start having more than so many files, like files named things, you realize that half the stuff in that file don't even really belong in there. They kind of belong in two places at the same time. Maybe. It just gets weird. But if you do one per module, it's kind of, you don't have any overlap between where you stick stuff and that. I don't know, in my opinion, system should be its own folder. Each component should be its own file. That's the other extreme you go. But then you start one file per function and whatever, it just gets a bit crazy. No. Like it's just it's just code. Like the code is all in the file. You want to find something, you just search for it. Like it's not difficult. Like, this is where the graphics is. It's just all in here, all the shaders. So any shader function, I just search for it in here, find it. Yeah, it's not difficult. Yeah. Yeah, right now this file is quite messy as well. It's not got an order to it or anything. It's just dump the GFX system specifically because we're prototyping a lot of things right now. So I'm just trying out a lot of things. So it's just very messy. But the rest of the systems are quite nice and clean inside. So they're quite easy to navigate. Yeah, so I think I want to try this out. So that seems pretty reasonable. Now we've got to have an else statement. So I think we are going to have to bring this back. So these can go again. Right. So it's half pixel size. I don't know why that's there. So calculate the half pixel size. But we've got this discriminant thing. So maybe we can reduce a lot of this maths. Yeah, I think that answers the question. Yeah. Distance from edge. So maybe we can use that and maybe project it across the... Hang on a minute. All right, we're not using that anymore. Right, so we're going to project that across the perpendicular vector again. Is that a bad idea? So all we need is that depth value. We could then just simply move that into there, I think, and then use that discriminant value. So we could probably move this. See, a lot of that is very much the same, it's just the depth, unfortunately. So maybe we can always populate a depth from that ray verse sphere function. So there is a t. So we should always set t. What can t be? The hit.t here at least needs to be set when this is false. We can set it to midpoint, because that is the depth along ray direction. So that should then mean we can move all of this out of the if statement, make it shared between the two branches, which would be great. Right, then we've already got the AA there. Oh, no. The AA is different here. Right, that's good, so we can share that. This will now mean in here, we might not need any of this maths, so long as we could say, hey, if we missed the event here, this thing, let's re-enable that. So long as we missed... Oh, so we got this in screen space here. So if the screen space is less than a... If we didn't hit and that is less than 0.5 and we enable anti-aliasing, then this is a much shorter if statement. And maybe we could share a lot of this stuff as well. So then the only thing that ends up being different is, yeah, maybe we can get rid of these things overall. Should be far simpler, but I just want to try it out first before we try and optimize it. Make sure it's correct. Okay. So we've now got the depth already. So this stuff goes. So the miss distance, we've already got that. This is a bit off. So our anti-aliasing alpha in this case would be, it's wait, less than, we want to say if it's greater than negative 0.5. That's what we're missing. So you want to then add 0.5, and this will get you from 0 to 0.5. Then we clamp it between 0 and 0.5, and that's it. So this gets you value from 0 to 0.5. Is that right though? Yes. Damn it, my phone's disconnected from chat again. Right, so closest point that we hit, we've got that now. Interesting. Then we recalculate some dirty normal. We could probably, again, share a lot of this code by getting the Raver sphere to always give us a normal back even if we miss. And so I think a lot of this can just be shared, but let's just make sure it's all correct and then we can optimize it, which would be really nice. Also have done. Yeah, a lot of this can actually be just shared. Okay, that's really good. So let's give this a run. that's bloody terrible. I've just made a very pixelized thing. Yeah. Well, that didn't go as planned. Looks interesting though. So yeah, clearly it's the anti-aliasing. Getting some big misses. No, it's a hobby project. I work on it 3 days a week. Tuesdays, Thursdays, and Sundays they'll get streamed. So yeah, we haven't been working on it for a few months. We've been working on it for we're on 109 now, so we'll be like 3.5, 3 and a bit months. We've been working on it for since July last year. So it's been nearly a year. Or is it June? It's probably coming up to a year in a month, yeah. It's about 11 months. So that's just been on the side while I've been working, basically. Half of the project has been trying to find the graphics art style first. So we're trying to render tons of spheres. We're just fixing the anti-aliasing. The shading that will come next. We've got like these also get smaller. There's like an LOD system. So yeah, there's the LODs basically. But yeah, super nice. Just trying to fix some rendering issues. Oh, Russ Musco. I appreciate this, man. Oh, for crying out loud. Right, I can see the code, at least. I'm imagining... I can imagine what you're doing through reading the code. So, big pixels, half the screen, pixels per... So frag chord is the pixel coordinate. If it's greater than half of the screen, 20, if not, okay. I see, big pixels on the right of the screen, nice. Hey, Wajula, welcome. How you doing? Yeah, for some reason I get stuck compiling shaders on my Linux box. Maybe I need to update my browser. Oh, I've got a PNG as well. Thank you, sir. Ooh, man. Absolute wizard. Absolute wizard. So, right. Here we go. So, we get the UV. You're rounding it to the grid. Damn it, browsers and their linear blending. Okay. Just made the pixels big. Fair play. Got it. Thank you. Finish up my Vulkan renderer after another small break. Nice. That's cool, Wajilla. Well done. So how far you got through the Vulkan renderer now? What features and capabilities do you have? Sphere projected to the screen. Radius and screen space. That's a bit questionable. Because you've got projecting a sphere into screen space isn't easy. Like, it's just going to be different. You're this, right? That. So if you have a perfect circle, it's easy, but yeah, when you have this sort of ellipsoid, not quite. Distance to the sphere edge. Bend symmetrically around edge. Right. So that's the radius and the ray to sphere edge. Yeah, distance to the sphere edge. Okay. Take radius. Okay. Yeah, it's very... Okay, yeah, that's a very simplified version of what we were building. Yeah, it's basically it. Awesome. Thank you, Rosmusco. Yeah, I don't think we can do this. Do it in screen space. We've got to get the results into screen space after, I think. Maybe. But I think that discriminant is not going to work. I think I'm using it wrong. I'm not understanding what it is. That's my issue. I think it is wrong. I think it isn't a distance from an edge. Let me disable this one. Right, so clearly all the issues are coming from when it's false. And we didn't hit. And it's greater. Yes, that would be the depth along the ray. We passed that out. Only when did hit is false is what we want. So that'd be negative value as well. Oh, but I didn't set this value. Whoops. Whoopsie whoopsie. Set that there. Try that. Right, did I re-enable the code? Yes, okay, so I think we fixed it. Right, so we enable the anti-aliasing, it does get a bit darker still. Yeah, we should really take a screenshot and see. Like, so it's adding... This is adding softness here. These are looking real soft here as well. Yeah, maybe should we simplify this and then we can... Yeah, let's simplify it and then we'll correct it, I think. So, right. So what's kind of interesting is this is the same closest point. We've basically always been able to get some closest point along the ray, which is nice. So it's a success to do something when it so I guess this is a very special ray-verse sphere function. Maybe... So what we're interested in knowing is the normal as well. So we can get the hit position. Cos plus t. Whereas here's what we might do with this function. It's a bit weird, but so that's just success false. We were outside the range, the acceptable range. Yeah, maybe I should have kept the old one before we changed it. It's always in Git, I guess. Right. So it's not within an acceptable range. There's t. So t in this case, this we're going to say we missed. But we still want to know that we still want to know everything about the miss for anti-aliasing. We're still running, that's good. Right. So here we can say hit.t is equal to midpoint, which is the depth, right? There's discriminant set there, which is kind of nice. Well, we only really care about it being set here, so I guess... You know, let's just put it all into locals. So t is there, t gets set here. And t gets set there. Alright. So this one makes it a success. We don't need this did hit anymore, because it's always a success if we miss. We want t... We can call this one instead distance from edge. So hit position, but it's not really a hit anymore. It's kind of the closest hit. But anyway. Well, it's not a hit, but yeah, closest position. And then a normal. So the normal is based on the hit position. So you've got the depth. Yep. divided by radius is wrong. That was a way of not doing a norm, but we're just going to normalize it. That was just an optimization to avoid the square root. But yeah, we'll have to square root. That's all right. Okay. So this means now we shouldn't need any more if statements. It's always a success. We can just... So the distance from edge will be from minus... So from minus 0.5 to 0.5. So if we add 0.5, right, so we'll say distance from edge, we want to anti-alias from negative 0.5 from when is negative to 0.5. So that's enough to say, okay, so we offset that, clamp it between 0 to 1, and then there you go. So we've already labeled this distance from edge in the output now. Hit.t. We've already got closest hit point, I believe. So let's just hit pause. Oh, so I've already calculated a normal. What's this about? No, there's already a normal. What is that doing? Yeah, we've already got a normal. That is not a normal, it's not normalized. Why are we doing that? No wonder why it could be so bright. That could be part of the problem. But yeah, so we want to move our normal into world space. So normal world space. So we'll just do the Right, so this was calculate sphere normal. So this is a thing where we tried to remap the normal. So what we needed is the vector to the hit position and not the normal. Right, okay. That goes now. So we just want to do the matrix multiply with the hits.normal. And that will give us normal in view space. Oh, world space, sorry. From view space. Now we throw that world space normal into the color and does the lighting. All straight to pixels. Why is my phone not showing the chat again? It's so bloody annoying. What's going on? So I got all the depth stuff. I just need to make it resizable. Too hard. Right, so you've got some basic 3D working, but not a resizable window. Okay. Nice. Well, you've got the swap chain to battle with. Still. Yeah, enjoy. And making it smooth resize. That's always fun. Or straight to pixels. Yeah, I see what you're saying. I could have made the distance from edge and just move it straight into pixels, maybe. Yeah. I don't know if I can move the sphere into pixels earlier. Color, AA, then blend. So we shouldn't need any of this anymore, which would be pretty cool. So that's now less code. That is simply less code now that gets to execute inside if statements, which is better for perf. I kind of solved this with resize on Windows by making a local copy of the JI input model and just sticking to draw call during resize. Interesting. Yeah, I wonder how people do it, because on Linux it's really difficult. I know it's possible because you can do it in the browsers do it, but I wonder how. I guess this one doesn't. I've seen it in Firefox. Bit jumpy. I've seen it in Firefox though. What? But yeah, I think part of the issue is that the thing gets resized. I was using non-blocking on X11, not sure what you mean. Alright, when you get the events, yeah. You can do that. But I don't think that's the issue. The issue is like the swap chain gets invalidated. So yeah, I find it difficult how you render an image in time to the screen. Shoot, this is the BVH ray tracer code. We're just going to disable it all because we're never going to use it again. We're just going to use it for looking at, for reference when we do a new one eventually. Okay, let's change the anti-aliasing around. So if we disable anti-aliasing, it's like, I'm not going to work. How weird. It was just this option here, literally. Oh, right, because the miss. There's a miss. Yeah. This counts misses. So the misses are not being blended. So to disable anti-aliasing, the new way is to be like, if not anti-aliasing and hit dot distance from edge, is negative. Cool. So that ought to be good enough. So that way we can disable the anti-aliasing and see it. Right, so it's still a bit brighter, but so now we're gonna take some screenshots and do some comparisons of these things. We're now getting a consistent 10 milliseconds. How have we made that worse? How's that been made worse? Like, we've literally now made, this is now worse code. Is it because we put a square root in there? No, we already had square root here. Um, um, yeah, how have we made the performance worse? Like, we only added an extra square root in here. Shall we remove the square root and see what happens performance-wise? Right. That changed it from 8 milliseconds to 10 milliseconds, I think. Yeah, from 8 to 10 milliseconds. Right. It's always calculating this stuff now. Even when you miss. So what we need to say is, if we miss, if we completely miss as well, discriminant is less than, yeah, we don't know. Right, so we need the size of a pixel. Pixel size at near clip plane. We need that to be passed in. So with this we can work out the distance from edge screen space. So we need to work that out. So after the discriminant we can work out, so that's the distance from edge in view space to screen space. So we don't have t yet. So to get t, you'll need to work out maybe that's enough. Maybe that's enough for t. I'm not sure it's correct though. No, you need to do the square root when it's greater than. Something like that. So I'll get your t variable. Then you want to say, hey, if this is greater than negative 0.5. we may have missed, but we still missed slightly. But we want to know everything. We want to know about slight misses and hits for AA. So now we calculate find the nearest hit that lies in an acceptable range. So if it's outside that range, cool. So now all of this goes, right? Wait. We want to miss. So here we want to say if it's missed by less than half a pixel or outside the ray boundary. Alright. So here we say we have missed by more than half a pixel or outside of the ray min/max depth. And there we go. So that should mean we're not doing all of this normal, this square root for all of those times we miss. So maybe that was part of the performance issues that we were seeing, because we would always go through here even if we missed by a lot. So I think that would have fixed that now. Shoot. When he's passing that pixel size at near clip, all of them need that. Wait, what is this? Is that draw shape 3D? This is the debug drawing code. So success and hit dot distance from edge and screen space, if that is greater than 0. Alright, so we fixed that, which is cool. So we don't need this anymore. This is kind of part of the hit stuff, so we just say hit dot. So that's already calculated in the Raver sphere. Alright, let's give that one a go. So this should be improved performance, hopefully. Shoot, I didn't calculate this. I need these just in global variables because they're just pre-calculated from constants and stuff. Well, not constants anymore. Wait, that's old. That's what I want. So instead of passing it into functions, we just need to read it from a global and done. But anyway, that's stuff to clean up and improve when we know what we're going with. It's no biggie. Global screen dims .y. Rightio, sweet, let's give that a run. Alright, so oh yeah, I was looking at performance, wasn't I? I just brought the camera back, let's do that. Right, so now the performance is down to 7 milliseconds. Here. Obviously, we want to make it way better than this, but when I was doing the anti-aliasing before, I think it was around this number. So yeah, at least we've brought it back to some... Yeah, I'm not sure what it was. I don't remember anymore. Yes, the issue with that was the extra square root that was happening. I wonder, do we have to do that, this square root, because we was dividing it by radius before, but now, so the distance from hit pause to center position, that is it one of these variables? It could be distance from edge, view space. I think that's it. Maybe. It might be wrong. Let's give it a go. I think we can just do div s. We probably should take some screenshots to see the difference, if there is any. Well, big difference, clearly. That's wrong. I wonder how quicker it is, though. Yeah, it brought it down to about 6 milliseconds. 6 point. It's a bit too noisy for the. But it did improve the performance doing that one less square root. Yeah, square roots are not good. Clearly. Should not do them. The discriminant's squared. Issue in it. So that's probably the answer. It's squared, isn't it? Right. I think that's the same as the. I have to get a screenshot to compare it. But that did increase the performance doing that. I have to get a screenshot to compare. Yeah. The issue is that when I toggled the anti-aliasing, I didn't see any difference anymore. Because I square rooted this. So I don't know what's going on. But yeah, let's do that. We'll take a screenshot. Because it could look identical. But you don't know until you've taken the screenshot, and damn it. Right. Oh, okay, well, it does, didn't it? Yeah, it did. Went good. Right, so we're going to take that screenshot. And I can't wait to get this built into the game. Be way better. Let's do a new from clipboard. We're in. So close, comment out this one. Do we see a difference in color in any way? Oh, it's definitely brighter. Definitely brighter. So the square root. So that's not the radius. Yeah. Okay, so I think we should undo that. We can't square root that. We'll just stick with the normalize. Maybe there's a way to optimize that later on. Just gotta have a think. There's 2 square roots in that function. Yeah. Right, so with this, with the anti-aliasing on and off, you clearly see a difference. Now let's compare some photos. So I wanna, let's do like a close and a far. Just something like this. One of those is disappearing. I'm a bit confused. But I want to try and get some that are maybe warping a lot. Huh? Maybe I can't. What was I doing earlier to get the warping ones? Oh yeah, they were just bigger spheres, weren't they? Right. Do something like this. Maybe. See, I doubt you get this as a problem, really. But yeah, let's see these big spheres for a second, and then we'll do the small ones. Be careful. Alright. Anti-aliasing on. Alright. So I'm gonna look around here. Off, on, off, on. So we are seeing it is putting a little bit of a touch there, which is nice. So that's cool. I'm only seeing it appear on the outside. I'm not seeing it appear on the inside. Like that. Which feels a bit problematic to me. But maybe it's because they're big. But they are also ones that have, you know, extruded a bit near the edge. But these ones here, the little ones really get it. It could be that square root thing that we're not doing or something. But yeah, say if we change the size of the balls, make them small again. Now let's take this screenshot. So anti-aliasing off. Anti-aliasing on. So it really deposits dark pixels at this point. In some cases. What are these bigger ones? They all get dark pixels. See, it works well for the small ones. But for the big ones, it's not really putting that's a hard image. Then you plug the A. That's good. So I don't think we're gonna have a problem with the small ones, but these big ones we won't see anything. So I wonder. See, it is the square root on this. Because this is like squared. I think it's, yeah, squared result. Working with squared things. So I reckon we do have to square root it, but we saw there wasn't much of a difference. So when I square rooted this, we saw there wasn't much of a difference. Oh shoot. So I think you're getting alright, but when you square root, does it get rid of the sign? That might be the reason. So if you have negative, because when you square it gets rid of the sign, but I forgot about. So you say 0.5, and you square root. Oh yeah, I forgot this calculator doesn't have square root, does it? Google it is. Yeah, it's the same as positive. So it's getting rid of the sign or the negative. So maybe you can copy sign. Do you? Yeah, because I think it's squared. Or you can always offset by 0.5 square root it. Oh no, you can't because it's in view space. Right, so I think if we bring that back, we'll say square root, and then you do a copy sign. And so let's try that instead. Still seeing nothing with the square root thing there. So maybe it's not the right way. Yeah, it's not right. Yeah, I didn't write anything wrong there. So perhaps that is not correct. Okay, that's fine. That is okay. We can work with that. So, alright, that's alright. Wait, there's a square root I'm missing. There, yeah. Okay, we put that back. That's good. Okay. Right, so I don't know if we have improved the darkness of it, yeah, which is a bit weird. Wow, I think we just made performance worse. This ain't good. So those if statements and what we was doing before, it was just better? Are we getting a lot of miss? You see, yeah, we need to debug this proper. So we should go to one sphere and color what is deemed as a miss, because that's clearly wrong. Okay. So in the prepare clusters, we need to move back into saying just render one level of detail. Oh, all this stuff to sort out as well with the fading. Great. Yeah, I want to just say always render this. Put it in there. You know what? This is how I'm going to do it. So put the first cluster in, just chuck it in there. And return. So you should only see the first cluster. Right, good. Then I want to disable the to make one of them. So I think that's enough. I was going to go and make it so we only have one sphere, but I've only got, yeah, 2 by 2 by 2. So with this is enough to, I don't know why these guys are popping off. Anyway, so I want to now color it based on the, because that performance thing was really weird. So I want to say, hey, if you missed, if you're less than 0 in screen space, can you instead make the color white? And I also want to, yeah, blend you on there, and then continue, and then break. So we're saying if you've missed, color it white, and if we've seen multiple pixels, then it's clearly wrong. Yeah. This is why the performance is bad. Look how terrible that is. That's clearly wrong. So I wonder then why that square root thing. So it clearly needs to be like the square root of it or something. So let's say square root of this, then, well, if you negate it, it's going to show everything, isn't it? Because it's, yeah, let's just say if this is negative, um, But the problem is, what do I want to do? So we want to say if we missed by yeah, I want to change this code here. Right, so what we did is we square rooted this, but then the problem with that is it's going to be... Oh, that still shows white? No way. Oh, it's always greater than 0. No. Oh, no, it's not. That's right. Why is there so much white area? Um, Mess around with that. No, let's put that back. Okay. So it's less than 0.5. Let's change it to 0.1 and see if it shrinks. Damn it. No. Right, I've clearly messed up something. Because initially it was just checking if discriminant is less than 0. Something's wrong. Right, then this is never set. Okay. Problematic. We want to save this a success. Alright, now we're not seeing any pixels. This is good. Right, so back to here again. Put it back to what it was. Awesome. Got this winner resize working nice. Actually, help me catch a bug with the way I was setting swap chain extent. Oh, yeah. Alright, so we're getting some pixels show up now, but not all. Right? So it's definitely not a problem with the square rooting. Say if we gave a pixel, how does that work? Right, we're getting some pixels, but this is not right. So clearly what I'm doing with this is wrong. And I need to find out why. Is it because of this thing here? And if I square root it, it would be less. No, it'd be more, wouldn't it? Right, that ruins it. So it's clearly not that. Um, um, D midpoint, take discriminant. Yeah, that's probably fine. Well, if you square root 0.5, it's 0.7, so it makes it bigger, which means you're going to discard more. Alright. Wait. Yeah. Hang on a minute. Yeah, and then if you square it. No. Yeah, it goes smaller, right. I think it's already squared though. Let's just square it and see what happens, because I'm a bit... So let's say copy sign. Let's just square that and then copy it from the discriminant. Let's just see what we get. Right, we get more that show up now, but I don't know how that's... But it's not correct, because you're only getting a few little bits. Yeah, more when you're really close. I wonder why the performance was really bad. Distance hasn't been super big. Maybe it's doing a lot more square roots now. This is the issue. Whereas it was doing the square roots less, maybe. But yeah, so this is clearly wrong now. So bring it to the near clip. Oh shoot. We're not taking it away from the sphere radius, are we? This is where the problem is coming from. Eros must go. I think that's what I did. Oh, that looks nice. Wait, you got it working on the... in 3D? Or is this with the same code basically? You've just moved into screen space before. Ross must go saving the day. But yeah, I think where we've done this wrong is that we're... Wait. No, maybe... No, okay. Let's see what Ross must go saying. Excellent. Nice. Focal length, right, I got that. That's in world space. So your radius in world space, excellent. Right, I got some maths. Yeah, nice. Love it. An A. Sweet. So you got the, yeah, you dot that, get the depth, like the T. Yeah, it's cool. C2 to C squared. Nice. The discriminant is different. Fair play. Linear discriminant by what you're saying. So you got A. Yes, that's what we did in the we did that. We did exactly this when we missed. This is the exact code we did when we missed. You calculate A. Then R, the radius in, yeah, take A. Yeah, we did this, but we used to add the pixel depth to RA. That's what I used to do. Then you're taking this discriminant, right? That's your pixel per whatever. Then symmetrically. Already subtract the radius squared, right? Yeah, no, I did subtract the radius squared, didn't I? Yours might be a bit different. Not sure. Blend symmetrically around the edge. So you're taking that difference between A and radius. Then your pixels per, right. Gotcha. So there's this special thing, focal length multiplied by C minus, right, so direction, yeah. Wait. Yeah, so you're going a vector towards the ray. Wait. Oh, right, okay, yeah, vector going towards the center. Yeah, length of that. Got it. I see. Yeah, there's a couple of square roots. Square root C2, right. Yeah, I see. Yeah, there's a few square roots. We did used to do something like this. But I think by commonizing it, we've maybe messed with performance a bit. It's doing... Yeah, I wonder in my old code... so in the old code when we missed... We only had... Yes, it's very similar to your code. Yeah, I think we can avoid the square roots, basically. We only have one square root. Or none. Yeah, I think there's a way to do it in squared space, maybe. Maybe not. Yeah, no, yeah, we did made that in squared, I think. Yeah, so you're taking the square root of that. Closest point on ray, the sphere distance squared. Yes, it's a squared. We had a squared. B and C are probably similar enough for computing this pixel size. I'm not sure what you mean by that, but yeah, when they get closer together, yeah. Hey Chandu, how's it going? Thank you, thank you. But yeah, what did we do with this in the end? So we took it squared. Oh, B and C are probably for, okay, so you don't need the square root, right? But yeah, when we did this linear thing, yeah, we kept it in squared space, and then we did the comparison. But we need it in non-squared space because we're trying to compute an actual value from it, right? I see. Right. Right. Right, you're saying they're similar enough when it's condensed down. That B and C will probably be similar enough. Okay. So you don't need to do the second square root. Right, that's interesting. But yeah, so we didn't do a second square root here, so when we missed, we just did this maths. Oh no, there is a square root. There, we only did it afterwards. Okay. Yeah, I wonder why the performance was getting so bad. Yeah, I think we're not... Because it just got worse. But yeah, I wonder if we can bring this into... CB A. So there's C. Well, there's not C rather. Oh yeah, yeah. Yeah, there is a C. B is when we dot it, there's B midpoint. It's the way you calculate then you calculate that A, isn't it? Yeah, so perhaps we need... So you're calculating that pixel in world space. Times pixel per world space. Right, so you can multiply the linear discriminant and bring it back into screen space, right? See. So we need to know that if we've missed by a pixel or not. I guess I can do it in here. Let's just bring this in. So we need to know somewhere around there, because I think we've already got C squared. Right, so A would be, what did I call it in the other one? Closest point on array distance. So that'll just be midpoint squared. I think. No, B was midpoint. C2. Yeah. Linear discriminant, radius in world space or in view space, but it's still fine. So it's no longer square that's there. So this just moves it into view. This was used so we can bring it into view space. So you want to get maybe like a distance from edge screen space. So that was that would be linear discriminant divided by depth, which is, wait, C minus ray origin dot, right, so that was just the length of that. Maybe you can work long enough with midpoint. Then divided by pixel size. Let's give that a go. Right, so we can work that in a bit. We don't need that now. Yeah, so discriminant still needs to get calculated. We'll leave that there. Wait, do we even need this anymore? This was used to discard. Yeah, maybe we don't need that anymore. So it's any of less than a pixel. T midpoint discriminant. Oh, what is T now? Or we reproject. Yeah, but if there's a hit, you need the discriminant. Right, let's keep the other one for the moment. To calculate the T. See, T would just be point, yeah. Right, let's try that version. Let's see if the let's see if we've got that pixel border. Right. Oh. This is the length, isn't it? Right, we do that here. Sweet. So that's got a pixel border now. Seems pretty good. Like it's not Yeah, that's looking like a pixel still. Zoom in a bit on that. Yeah, still looking like a pixel. You don't need all the pixels lit, right? What do you? Yeah, that's fine. Um, if the distance from edge screen space is less than. Okay. So. Yeah. So I guess let's remove this debug thing and wait, yeah, add 0.5. Yeah. Okay, so now let's go back to this code where we force it to only be one cluster. We'll go back to the other code as well where we have 4x4 instances. Okay, so we go in. It's a bit jumpy with the performance still. I don't know what I did. BS, check the AA. Let's grab 2 screenshots. Yeah, I'm not sure how much of an improvement this is to be. Oh, crap. I gotta do another. Hi there, Dandy McGee. How's it going? Dandy McGee. How's it going? Yep, tons of balls. Let's do another one of these with the anti-aliasing on. Right, let's check these boys out. They look quite soft there. Yeah, so there's a bit of softness that comes on. It's much better now. Quite subtle there. It's good. If you look at the ones further away, we're still getting. Right, we're getting a dark pixel. I guess it's. Yeah, so we just got to fix that dark pixel problem now, I guess. And that's what we was hoping to fix with this. But I guess it's yeah. Maybe there's no escaping it. Softening the image out. Maybe there's no softening. Yeah, when we're softening it. But the bit I'm confused though is how we just made the perf worse. I had worse code, I'm pretty sure of it. There was 2 if statements. I don't know what I did. Maybe I didn't make it worse, but it feels like it is. When I move the camera now. So we've got such a smaller if statement. And I'm pretty sure we're not putting more things through this if statement anymore. But maybe in this reverse sphere we made this worse. I know we compute. Yeah, so we've got 3 square roots now instead of 1, that was maybe it. But if we've got this, but we've already square rooted here. Closest point on ray to sphere distance. That's enough for the normal. And if we could use that there, that could remove the square root. Linear discriminant. And you already got the distance along the ray. Right. And you take away that discriminant there to get. Yeah, we've got to leave that one in. But I'm thinking about this square root here. It's going to get you that and not that. Yeah, that's not the right. Closest perpendicular point. That's what that actually is. So we used to just divide by the radius, but that's now no longer it. So your radius can be short, it could be longer. So I guess it could be this. Yeah, but it's perpendicular though. Yeah, it won't work. Maybe. I got an idea. So I think you can do divide, and then probably sphere.radius plus. So this will give you negative when you're on the outside, positive when you're on the inside. So only when we're on the outside do we want to change this. So you basically max the value of 0 and negate of linear discriminant. I think that should be the optimization. I don't know about the colors. We should probably screenshot that. I don't know, that time is not. Anyway, let's do the screenshot first. so I can see the colors. See if that normal's correct or not. Alright, it's looking similar, if not the same. I'll do another grab. I think I nailed it. Well, at least the inside one needs to be... Huh. Yeah. Alright, let's look at that, see what the difference is. Right, there appears to be no difference. Let's double check quick. I'm copying that again, pasting it over. Yeah, there's no difference. Okay, so I think we found a way to optimize it. I don't know if it's optimized though. Because that one was... Yeah, about 7 point whatever milliseconds on that ray tracer. But then if we just do the divide instead, that avoids the square root. It's about the same. It's not jumping around anymore, I think. You know, maybe that jumping around was when we increased it to 4 million spheres to bin or something. Potentially it's not been since we changed the AA code. Oh, that really felt weird. Okay. So maybe it is removing hitches. No, I'm still feeling it a bit here. Maybe it's not as bad though. A bit better. But yeah. Well, what to remember as well is when you move the camera, we get gaps in the... Yeah, it's probably where it's coming from. We get gaps in the occlusion buffer, so therefore things won't be occluded properly. So that's where the spikiness is coming from when we move. That is fine. That's another problem to solve later when we actually settle on it. Yes, I guess it's just this, it is still darkening when you have anti-aliasing on. But I guess the anti-aliasing is more correct now. So now it's going to alpha blend, where alpha blends the LOD changes, you see these slowly fade away and fade in. I wanted to improve that today, but yeah, we don't have the time, which is a shame. So what we might do is just save it for when we get back, to improve performance, and just mark this off as done. I think that's what we'll do. Yeah, so we'll mark this as done, and we'll move on to something else next stream. So next stream we're going to be working on a texture viewer, because as you're seeing, taking screenshots has just been crap. So I posted on the Discord. There's links to that in the here in the chat. But basically, yeah, basically we want to be able to select a texture at a specific point when it's been changed by a shader, so we'll have a history of all the points at the time it'll be changed in the frame. The darkening that is left is probably from the bias in the normal direction of the transparent pixels. Yeah, so the one that's incorrect, isn't it? You're saying we should use a different normal, like one from the middle of the sphere or something. Is that what you're suggesting? Yeah, so essentially we want to be able to make a way to take some screenshots, view those in the game. So press a button, take screenshots, view them in the game, and they'll be viewable by this texture viewer. And we want to be able to switch between a couple of screenshots. So we're not jumping into Krita and doing all this dancing with a screenshot tool. And we want to be able to view any texture that's been written to throughout the lifetime of the frame and view it as before a shader and after a shader. We want to be able to pan and zoom, see different MIP levels. We also want to be able to view slices of 2D slices of 3D images or 2D arrays. And we also want to be able to reinterpret pixels from special formats. So yeah, we might just have our pixels might just mean something random. Well, not random, but just something, there might be packed information per pixel. We want to be able to interpret that. And then also overlay over the game screen, because we might not want to, we might want to view the texture on its own in this viewer, but also we might want to view it overlaid the whole game, and we can sort of see it in a small view, like we've done in the past, right? We had the occlusion texture up here in the past as a quick debug. We want to make this system more integrated into the engine, and yeah, just cut down on this debugging time of switching tools. Yeah, nudge it towards the center of the sphere. Okay. Right, okay. I wonder if you could. Problem is it's going to be perpendicular, so you got to get it up as well. Yeah, the issue is that it's perpendicular. It's that. So if I just nudge it inwards, it's not going to help with the normal much. I need to nudge it. Kind of that way. Yeah, I guess it's something we can look into some other time. Oh, nudge it in the ray direction. Right. That's a lot more elegant, isn't it? Yes, use the ray direction. And just... Right. It's going to mess up the division thing though, but... Yeah, that optimization won't be able to take place anymore. But I guess it wasn't really helping. I don't know. But yeah, I see what you're saying. Let's have a bit of fun. Give this less than 0. hit pause. Oh, it's the T, isn't it? Yeah, reduce T a bit. T minus equal linear discriminant. One of that. No, it's still dark. Wait, if it's less than, I just made it even more. No. Hmm. Maybe it's not. Yeah. Alright, something to look into some other time. But yeah, thank you for that, Rosmus. Go, appreciate it. But yeah. Right, so the next stream will be on Sunday. We'll do this texture review thing, take a break from all these spheres, get something helpful in the code base. I'm also going to try and post to YouTube as well, a shortened version of the stream. I'm going to be trying out that next stream as well. So I put a marker in, so I'm going to see how that shows up in the producer thing after the stream and just see how helpful that is. And the plan is to cut down videos into devlogs and probably to maybe cut them down to about 10 to 20 minutes. So yeah, there's the YouTube link there. That's where they'll be posted. Cut them down to about 10 to 20 minutes so people can watch recaps of the stream, basically. So I've got to be intelligent where I place these markers so I can save myself time after the stream, basically. So that's the plan. Right, so next be on Thursday, 6:30 p.m. So 7:30 p.m. GMT +1. And yeah. Wait, Sundays at 6. Yeah, Sundays at 6, Tuesdays and Thursdays at 7:30. Okay, it's fun one to raid. There's a new goal. Alright. Right. I think I might just bail. Gotta go. But yeah, I'll upload the code to the repo for those people who have access to the code. Oh, I was Raymart streaming. Why? I follow Raymart, don't I? Huh? Don't I follow Raymart? Crying out loud. That's not good. Thank you, Cranston. Appreciate it. But yeah, thank you for coming, guys. I'll see you on the future one. And yeah, have a good start to your weekend. I'll catch you later.